dirt under your boots, the smell of diesel in the air. That's farming that's been farming for 100 years, and now it's changing. Quietly, slowly, but it's changing. The smell that's disappearing. A farmer in Iowa wakes up at 5 in the morning. He walks to his shed, he turns the key. No rumble, no smoke, just a hum, just a hum. That moment is already happening on farms across the United States, Europe, and parts of Asia. Electric tractors are not a concept anymore. They're in fields right now, pulling plows, lifting loads, running full days. The first commercially available electric tractor hit the market in 2019. By 2023, over 40 manufacturers had announced electric or hybrid models. That number keeps growing. The question isn't whether electric tractors work. The question is, why did it take so long? Diesel engines dominated agriculture for over a century. They were reliable, powerful, easy to fuel. But diesel engines are also loud, polluting, and expensive to maintain. A single large tractor can burn through 30 to 50 gallons of diesel per day during peak season. At current prices, that's over $150 every single day just for one machine. Multiply that across a working farm. The numbers get painful fast. The battery problem nobody talks about. Here's the honest truth about electric tractors. The battery is the hardest part, not the motor, not the controls, not the software, the battery. A modern electric car battery weighs around 500 pounds. A tractor doing heavy field work needs 3 to 5 times that capacity. That's over 1,000 pounds of battery just to run 8 hours in a field. Weight matters enormously on a farm. Compacted soil loses productivity. A heavier machine means more soil damage. Some companies solved it by limiting the work. Smaller tractors, lighter tasks, shorter shifts. The Solectrac E25, one of the first electric tractors sold in America, weighs about 3,500 pounds. It runs for 4 to 8 hours depending on the task, perfect for a vineyard, for a small organic farm. Not for a 1,000-acre corn operation in Nebraska. Not yet. The giants who moved first, John Deere, didn't ignore this. Nobody ignored this. John Deere, the most recognized name in agricultural equipment, unveiled its first fully electric concept tractor in 2022. It was massive, autonomous, designed for large-scale fieldwork. No cab, no driver, just cameras, sensors, and electric motors doing the work. The machine ran itself around the field while the farmer watched from a phone. That wasn't a demo for investors, that was a field test. Real dirt, real rows, real data. CNH Industrial, the company behind Case IH in New Holland, launched the T7 electric power tractor the same year. It used a modular power system. Farmers could swap between a battery pack, a hydrogen fuel cell module, or a diesel hybrid unit. Same chassis, different energy source. That flexibility was intentional. The company understood that not every farm is the same. Not every grid is reliable. Not every region has charging infrastructure. The modular approach was an admission. There's no one-size solution here. What charging actually looks like. Picture this. It's 4 in the afternoon. The field is half done. The tractor's battery is at 12%. You drive it back to the barn. You plug it in. You wait. That's the part nobody shows in the brochures. Charging a large agricultural battery doesn't take 30 minutes. It takes hours. Some systems take 6 to 8 hours for a full charge. That means planning your work around the charge cycle, not the weather, not the crop, the battery. Fast charging systems exist. Some manufacturers offer DC fast charging solutions that can bring a tractor to 80% in under 2 hours. But those chargers require serious electrical infrastructure, 3-phase power, high amperage panels, dedicated circuits. Installing that on a remote farm costs tens of thousands of dollars before you even buy the tractor. For large farming operations, that investment makes sense over time. For small family farms, it's a real barrier. The unexpected winners. Here's the part that surprises most people. Electric tractors aren't making the biggest impact on giant corn and soybean farms. They're making the biggest impact in specialty agriculture, vineyards, orchards, greenhouses, organic vegetable operations. In a vineyard, a diesel tractor running through narrow rows fills the air with exhaust. That exhaust affects the vines. It affects the workers breathing it all day. An electric tractor running the same rows is silent. No fumes, no vibration shaking the fruit loose. No exhaust smell mixing with the harvest. In France, the Champagne region started adopting electric tractors in 2021. Premium wine producers saw it as a quality investment, not just an environmental one. Quieter equipment meant less stress on the vines, less stress on the workers, and it became a marketing point. Our grapes are harvested with zero-emission equipment. That sentence moves product in certain markets. Greenhouse operations have been even faster to adopt electric power. Run a diesel engine inside an enclosed greenhouse and you're poisoning everything: plants, workers, air quality sensors. Electric solves that completely. No emissions, no heat plume from the exhaust, no noise bouncing off the glass walls. Several large greenhouse complexes in the Netherlands and Canada had already moved to full electric ground equipment by 2022. The autonomy layer. Electric tractors didn't just bring cleaner power to farming, they brought something else. Software. A diesel tractor is a mechanical system. An electric tractor is a computer on wheels. Electric motors respond instantly to digital commands. Throttle, braking, steering, all of it can be controlled by code. That made electric tractors the natural platform for agricultural autonomy. Monarch Tractor, a startup out of California, built their entire business model around this idea. Their MKV tractor is fully electric and fully autonomous. It can plant, spray, and cultivate without a driver. A farmer programs the field boundary into an app. The tractor does the rest. If something unexpected appears, a person, an animal, an obstacle, the machine stops. Farmers using the system reported saving hundreds of hours per season in labor costs alone. This matters because labor is one of the biggest problems in modern agriculture. Finding workers to operate equipment is increasingly difficult. In the United States, farm labor shortages have left crops unharvested for multiple seasons in a row. An autonomous electric tractor doesn't fix that problem entirely, but it reduces dependence on operators for repetitive field tasks. That's significant. The grid problem. There's a conversation the industry doesn't love having publicly. The power has to come from somewhere. An electric tractor plugged into a grid powered entirely by coal isn't zero emission, it's just moved the emission somewhere else out of the field and into the power plant. For electric tractors to deliver on their environmental promise, the energy source matters. In states like Iowa, Nebraska, and Kansas, America's farming heartland, the grid is still heavily dependent on fossil fuels. The carbon math on an electric tractor in those states is complicated. It's better than diesel, but not by the margin the marketing materials suggest. In California, where the grid is significantly cleaner, the math changes. The same tractor, different grid, different carbon footprint. Some farmers have solved this by generating their own power. Solar panels on barn roofs charging tractor batteries directly. In that scenario, the energy really is clean and the fuel cost is essentially zero. A farm in Oregon documented their Solar 2 tractor setup in 2023. Their annual fuel savings after installation costs over $22,000 per year. That's a real number. What happens next? Solid-state batteries are coming. They're not here yet. Not at scale. Not at a price that works for agriculture. But when they arrive, they will store more energy, way less, and charge faster than anything available today. Every limitation that currently holds electric tractors back from large-scale row crop farming gets smaller with better batteries. Most analysts place that inflection point somewhere between 2028 and 2035. That's not distant. That's one tractor purchase cycle away for most large farming operations. The farmer in Iowa who bought a new diesel tractor last year, his next one might be electric. Not because someone told him to, because by then, it'll be the cheaper machine to run. And on a farm, the math always wins.